friends, good evening. Today we will discuss all the GATE previous year questions topic wise for the subject electromagnetic theory. We will discuss our first topic, Coulomb's law, Gauss law, and electrostatic potential. So let's start with our first question from the year 2020.
So in this question, we have given a charge that is moving with a uniform speed in an cylindrical region. This charge enters the cylindrical region at time is equals to 0, time tt is equals to 0, and leaves this region at t is equals to tau. So now we have to find what? We have to find the time dependency of the total electric flux. So how can we do that?
It can be any surface. We need to remember the only one point, that is the total electric flux. The total electric flux through any closed surface will always be equals to total enclosed charge by epsilon naught. Okay, so here we can see that the only charge we have given here is we have given a cylindrical surface at t is equals to 0. The charge enters the surface, that is the charge q, and it leaves the surface at t is equals to tau. So inside the surface we have total electric flux q by epsilon naught, and outside the surface we will have electric flux is equals to 0. Okay, so inside the cylindrical surface the total electric flux is constant quantity, so we can easily build a graph between the electric flux and the time, that is t. Okay, we can clearly see that at t is equals to 0, initially the electric flux has the constant value q by epsilon naught, and up to t is equals to tau it will remains the same, that is constant. Okay, and after the time t is equals to tau it will be 0. Okay, after t is equals to tau greater than or less than, we will have what? Total electric flux is equals to 0. So you can see which option is the correct one. So here D option is the correct one. Okay, D option is the correct answer. Okay, now question number second is from the year 2019.
So in this question we have given an infinitely long thin cylindrical shell whose axis is along the z-axis, and we have also given the surface charge density sigma naught cos phi, where sigma naught is the constant and phi is the polar angle. So now we need to find the magnitude of the electric field inside the cylinder.
The electric field is given as lambda by 2 pi epsilon r. Okay, where r is the separation of the point through which we have to calculate the electric field. So let's assume this is our cylinder and we have any point on this axis. Okay, and this is our infinitely long cylindrical shell. So let's assume inside the cylinder we have assumed, because we have to calculate the electric field inside the cylinder, so let's assume any point inside the cylinder, that is P. Okay, now we can take a Gaussian surface. Okay, Gaussian surface around it. Okay, and we can take a Gaussian surface. It is a thin cylindrical shell, so we can take the section of the cylinder perpendicular to its axis. Okay, so if we take that, let's assume this is the section, this one is the section of the cylinder vertically upward. Okay, that is perpendicular to this axis. This axis is the z-axis. Okay, so this section is the perpendicular to the z-axis, and here we will have the x-axis. Okay, and this is, you can see that how can I, okay, so you can see that this is the z-axis, this is our z-axis, and this axis is our y-axis. Okay, now here we have our origin And now if we take a small segment of this area, okay, this is small segment, let we take this is small arc. This arc has length rd phi, okay, where phi is the angle of this small arc, this segment. The phi is the angle which this segment is making with the x-axis, okay. And now let's the segment is r, and this length is r, okay. And if this length, that is the radius of this curvature, is r, and the segment is making angle phi with the x-axis, then the length of this arc will be rd phi, okay. And now we can extend this line backward, and this is the direction of our electric field due to this segment, okay. And if we see that, I'm not able to focus it, okay. So this angle will also be phi, okay. And now we can see that now we have to find the electric field dE, okay. So dE will be is equals to what? dE at the origin O will be is equals to sigma r d phi by 2 pi epsilon r. This thing is taken from this expression, okay, where lambda can be related to the surface charge density as this. The linear charge density lambda will be equals to what? The surface charge density into the length of this arc, okay, that is rd phi. It can be easily derived, okay. It is not that hard. We can see that charge enclosed will be equals to lambda by, that is linear density, into multiplied by the length, okay, length of the cylinder. And the surface charge density of the cylinder will be equals to sigma multiplied by 2 pi r l. So here we can see that sigma and lambda can be related as lambda is equals to sigma into 2 pi r, okay. So here the 2 pi r is the term when we integrate this from, if we integrate r d phi from 0 to r, 0 to r, and 0 to 2 pi, then we will get 2 pi r, okay. So it is not that hard. Now I think it is clear up till now. This electric field will be directed along OS, okay. This electric field will be directed along OS, and it can be resolved into two segments, okay. That will be, that can be resolved as that can be resolved as sigma cos phi d phi by 2 pi epsilon naught along cos phi, that is along OX, okay. So here along OX it will be cos phi, and along OY it will be sin phi, okay. This electric field can be resolved into two parts, along x and along y direction. Along x direction we will have cos component, and along y direction we will have sin phi component, okay. So we can see that OY component will be vanishing, will be vanished when we integrate this expression. I'm saying about sigma, this expression, sigma cos phi sin phi d phi by 2 pi epsilon. If I integrate this part, we will get the resultant value is equals to 0. But if I take the another component, that is the cos component, that will be along OX direction, I will get what? I will get 0 to 2 pi sigma naught cos square phi d phi by 2 pi epsilon naught, right? It is that simple. Now if I integrate this, what I will get? I will get sigma naught is a constant, and 2 pi epsilon naught is also a constant, and if I divide 1 by 2 and multiplied it, then we will get 2 cos square phi d phi from 0 to 2 pi. Then I think you can understand why I'm taking the limit 0 to 2 pi, because because I need to calculate the electric field through this point all over the surface, right? So the phi angle can be from 0 to 2 pi. That's why I'm taking the limit 0 to 2 pi. Okay. Now 2 cos square phi can be easily written as, we already know that 2 cos 2 phi is equals to 2 cos square phi minus 1. So here, from here, 2 cos square phi will be equals to 1 plus 2 cos 2 phi. Okay, and from here we can say that sigma naught by 4 pi epsilon naught 0 to 2 pi 1 plus cos 2 pi 2 phi d phi. And now if we integrate this, we will get sigma naught by 4 pi epsilon naught multiplied by 8 pi, and from here we will get the value sigma by 2 pi 2 epsilon. Okay, so this will be our final answer. So option B is the correct option. Now this will be our last question. Please read it carefully. You can also pause the video if you want. This will be our third question, that will be from year 2015. In this question it is very simple. We don't have to do much. हमें 4 forces given है, F1 vector, F2 vector, F3 vector, F4 vector. Okay, and what we will do, we have to confirm that whether these forces are conservative or non-conservative. So to find the forces are conservative or not conservative, we will do what? We will find the curl. If curl of any force is 0, then it is a conservative force. Conservative force. Okay. Now if we find the expression for F1 vector, we will observe that this, on calculating this, I hope you can easily calculate the curl of any vector. Let me show you how can we do it. Curl of any vector quantity can be equate to 1 by r square sine theta, and the determinant of it is given in spherical symmetry. Okay, so r cap, r theta cap, and r sine theta phi cap. These are our three components. Okay, and now this is the curl, the value of curl, del by del r, del by del theta, and del by del phi. You need to remember this. Okay, this is very important. And our first term that is already given in the question for r cap is minus r by capital R square, and for r theta there is no quantity given, and for this also. Now if we calculate this determinant, we will find that this will be is equals to 0, and same for the force F3. Okay, if we find the force for F3, the curl for F3, then it will be is equals to 0, and if we find curl of force F2, we will see that the value will be 3ky square x cap plus 3kx square z cap. And for curl of the force F, I need to show you this, r cap, r theta cap, r sine theta phi cap, del by del r, del by del theta, del by del phi, 0 0, r sine theta. It is already given in the question. So if we find this, just take this thing common and cross multiply this. You can easily find the determinant of any vector. Okay, so we will get what? We will not get it is equals to 0. We will get r cap k cos theta multiplied by 1 by r square sine theta. Okay, or maybe you can write it as 1 by r square cot theta, k by r square cot theta r cube. Okay, so we can see that f1 vector and f3 vector are the conservative forces, and rest, that is f2 and f4 vector, are the non-conservative forces. Okay, so which option will be the correct option? I think the option number D. Option number D is the correct one. We will discuss remaining questions in our next part. Thank you.